Hello, my name is Alondra, and today I'm going to explain what ANOVA is, and we're going to do a problem with it. So ANOVA is analysis of variance, and it is used when you're comparing two or more means. The difference between ANOVA and a t-test is that a t-test is only good when you have two categories, since it is testing difference of means between two different ones like population and sample. Meanwhile, the ANOVA, you're looking at the means of many groups, so it could be more than two. ANOVA has three basic assumptions. Number one, it must have homogeneity of variance. Number two, populations must be normally distributed. And three, each value is sampled independently from each value, so we have to have simple random samples. Okay, so ANOVA tests the nonspecific null hypothesis. The nonspecific null hypothesis is called omnibus. The null hypothesis in ANOVA is that all the sample means of each group are the same. When the null is rejected, it means that one population mean is different from the other means. However, the null hypothesis when testing ANOVA does not tell you which of the means is different from the others. Okay, so when talking about ANOVA, there is two things to address. One of them is the between subject factor, and the other is the within subject factor. Between subject factor is when different subjects are used for different levels of the factor. The factor is the independent variable. And there is a comparison between different groups of subjects. For example, you try to see how one group and another group compare when you give them two different medications or the same medication. The within subject factor is when the same subjects are used for the different levels of the factor. The comparisons are between the conditions and the subjects. For example, if you're doing an experiment and you give each subject 3 different types of allergy medications, that would be your within subject factor. From these definitions, we create mean of squares error and mean of squares between. Mean of square errors, which I will sometimes refer to as MSE, is sometimes written like this. Some important things to note is that MSE estimates standard deviation regardless of whether the null is true. It is based on the differences among the scores within a group. Next, we have mean of squares between, MSB, which I will also be referring to as. I'll insert the picture. MSB is based on the differences among the sample mean and estimates standard deviation only if the population means are equal. If they are not equal, it estimates a larger quantity than SD, standard deviation. Some important things to know is that if both population means are equal, both MSE and MSB should be the same. Now I'm going to go into a little bit more specifics. Here is the equation for the sum of squares condition, MSB. The top part is the sum of squares of condition, the first part of the equation, the top part, and the bottom part is the degrees of freedom. Now let's get a little bit more specific. These are the two formulas for the top part. The green one is used when the number of scores in each group is the same, and the blue one is used when the scores are not the same. So for the bottom part of the equation, the degrees of freedom, it is the number of groups minus 1. Now on to the mean of squares error. There is only one equation for the top part, and it is the one in red. The x exclamation point I are for the scores in group 1, and the M1 is for the mean of that one group, of group 1. The bottom part is the degrees of freedom and is calculated as the total observed minus the number of groups. Lastly, the equation for sum of squares error is the sum of squares total minus the sum of squares condition equals the sum of squares error. Now that we've cleared that out of the way, let's talk about the F ratio. So the F ratio is used to see if there's a significant difference between the groups. If the F is larger than the critical value, then you reject the null. The critical value is found by using the degrees of freedom from MSB and MSE. And the way you find the F ratio is you divide MSB over MSE. Okay, now let's test what we just learned. I modified a practice problem that was given to me. So, Caesar is doing a study to see how many hours his 3 friends spend on their computer for 3 days. Rip Caesar, he's not gone, he's just always in the videos. Miss you, Caesar. So let's find the means of square errors. So we need to find the mean of squares of the scores in group 1 minus the mean of that group. So here's my work. Please pause it if you need to look at it more further. And the answer for the top part of the formula is 40. Now we need to find the degrees of freedom. So we have to do n minus k. N is the total observed, which is 9, and k is 3. So our degrees of freedom is 6. Okay, so after we divide the top and the bottom, our answer for MSE is 6.6. Now on to the mean of squares between, MSB. Since we have the same number of scores in the groups, we will use this formula. The n is 3, the m is plugged in each time for the respective mean that we're representing, and the gm, the grand mean, is 4. The degrees of freedom is 3 minus 1, which is 2. At the end, our MSB comes out to 1.5. Now, to check if there is a significance difference between the means of the groups, we will test for Fisher's LSD, which is sometimes referred to as Fisher's ratio, which is the one I mentioned before as F ratio. Our ratio for F is 0.5. So now that we have our F ratio, we need to find our critical value. So we take the degrees of freedom from MSB and MSE and we look at our F chart. I forgot to mention that our significance value for this problem was 0.5, so we need to look at a chart that has with a significance value of 0.5. So now that we found our critical value, which is 5.14, we have to compare it to the F. Since the critical value is greater to our F ratio, we accept the null hypothesis and state that there is no correlation or association between the means of the groups. So that's it. That's all I have for today, and I hope this video was helpful, and I hope you have a great day.